Hi there, welcome to the Online Chemistry Tutor YouTube channel. My name's Steve Smith, and in this video clip I'm going to introduce you to the method for determining the formula of an ionic compound for GCSE Chemistry. In the exam, you will be provided either with a data sheet containing all the ions that you will require, or the ions will be included in the question itself. There's one thing that you need to remember. For the formula of an ionic compound to be correct, all of the charges must add up to 0. Ionic compounds contain positively charged ions and negatively charged ions, and the key is ensuring that those charges add up to 0. And you achieve that by using different quantities of the positive and the negatively charged ions to achieve that aim. So let's illustrate this with an example. The question is, what is the formula of potassium chloride? You look at the two sets of columns of positive and negative ions. The first ion in the name of the compound will be the positive ion. So you look for the potassium ion on the left-hand side, and you see it's there 4 down. You then look at the right-hand side and you look for chloride, and it's there right at the top. So you've found the two ions, potassium and chloride. And for me, the easiest way to do it is to write them out next to each other with the charges. And then it's just a case of adding the charges together. So potassium is +1, which is just 1, and chloride is -1. So when you add a minus number, it's a plus minus, which makes it the same as a minus. So it's the same as 1 minus 1, which means that the charges add up to 0. We don't need to do any more with this. There's 1 potassium ion, 1 chloride ion. So the correct formula of potassium chloride is KCl. Let's try a different example. Lithium oxide. So just like before, you find the ions on the left-hand side and the right-hand side. If you need to look them up in the data sheets, we have lithium there. We have oxide just there. Li is Li single plus. Oxide is O2 minus. If we try and add those together, we have 1 minus 2. 1 plus minus 2 is the same as 1 minus 2. And this time, it will add up to -1. That's no good. We have too much negative charge for this ionic compound. So we need to solve this problem. And we solve this problem by introducing more positive charge. I said before, you can use more of the positive or more of the negative ions. If we have a situation where we have too much negative charge, we can try introducing some more positive charge by putting in another positive ion, in this case another lithium ion. So now we have a sum of 1 for the first ion plus 1 for the second lithium ion minus 2. 1 plus 1 minus 2 equals 0. So the charges are now balanced. We have the same quantity of positive and negative charge. How do we express this situation in terms of the formula of the compound? Well, we need to show that the compound contains 2 lithium ions and 1 oxide ion. And we do this by putting a small number 2 just to the lower and to the right of the ion that contains 2 of that particular ion. So in this case, we have 2 lithium ions, so we write Li2, and then just next to that, we write the O for oxide. Li2O, that's the formula of lithium oxide. Here's another example, magnesium sulfide. We find magnesium from the left, we find sulfide, not to be confused with sulfate, on the right. Write the ions out next to each other. Mg is 2 plus, sulfide S is 2 minus. We add the charges up, 2 plus minus 2 equals 0. The charges are already completely balanced. What that means is that we don't need to use more magnesium ions and more sulfide ions. So the formula of magnesium sulfide is just going to be MgS. Okay, let's try another one. Calcium chloride. Again, look up calcium, look up chloride. Ca is 2 plus, Cl is a single minus. Add those charges together. We have plus 2 plus minus 1. 2 minus 1 is 1, or plus 1. So that's not going to work for us. If we have one calcium ion and one chloride ion, we're going to have a compound that's got too much positive charge. So if you have too much positive charge, what you have to do is introduce some more negative charge. If we try adding a second chloride ion, then the sum becomes 2 minus 1 minus 1, which equals 0. How do we show that our compound contains one calcium ion and two chloride ions? You've probably guessed it by now. We put a little 2 just to the right of the chlorine in the formula, the chloride ion, to indicate that this is the formula of the compound calcium chloride. Okay, I'm going to give you one more example, and then I'm going to give some for you to have a try at. Aluminium is right at the bottom. It's Al3 plus. Oxide for aluminium oxide is towards the bottom of the negative ions list. So we have Al3 plus and O2 minus. If we add those charges together, they add up to 1, or plus 1. So we have too much positive charge if we just have one of each ion. That's no good. We need some more negative charge. The problem here is that as much as we would like to use an ion with a charge of minus 1, we're not allowed to do that because the formula of the compound, or the name of the compound, is aluminium oxide. We can only introduce more oxide ions. So if we were to put a second oxide ion in there, then when we add up the charges, we have 3 minus 2 minus 2, which is minus 1. So we've gone the opposite way. We've now made it to negatively charged. So we can put some more positive charge in there, a second aluminium ion. But if we have 2 aluminium ions, 3 plus 3, and 2 oxide ions, minus 2 and another minus 2, they'll add up to plus 2. So we've gone from being 2 negatively charged, a charge of minus 1, to being 2 positively charged with a charge of plus 2. However, if we introduce an additional oxide ion, our charges, when added together, come to 0. Our charges are now balanced. We need 2 aluminium ions and 3 oxide ions. So how do we represent that in the formula? 2 aluminium ions, Al2, 3 oxide ions, O3. Okay, so time for you to have a go. There are 3 formulae or names of compounds on the screen. You have to work out the 3 ionic formulae. Pause the video at this point. I'm going to go through the answers in 5, 4, 3, 2, 1, now. Just like before, silver fluoride. Look up silver on the left-hand side, it's the 3rd one down. Ag single plus. Look up fluoride on the right-hand side, it's the 3rd one down the right-hand side, it's F minus. Ag single plus, F single minus, those 2 charges cancel out. The formula is AgF. The second one is copper 2 sulfide. Copper is just over halfway down the left-hand side, copper 2, and sulfide is 3 from the bottom on the right. You'll come across Roman numerals next to certain metals. They tell you what the charge is on that metal. So if you're asked to state the name, you must include the Roman numeral, but you don't include the Roman numeral in the formula. So copper 2 is Cu2 plus, sulfide is S minus. Those 2 charges completely cancel out. You don't need to do any more. The formula of the compound is CuS. And then the third example, iron 2 sulfide. Well, we're still using sulfide, third from the bottom on the right. I think I said iron 2, I meant iron 3, of course. Just checking you're still listening. Iron 3 sulfide. Iron 3 is Fe3+. Sulfide is S2-. This may look familiar. We have the same charges here that we came across when we had aluminium oxide. And we overcome the problem of the charges in that example by having 2 of the aluminium ions with a charge of 3+, so we need 2 of the iron ions with a charge of 3+. And if we have 3 sulfide ions, each with a charge of 2-, we have a total charge of +6 from the iron, we have a total charge of -6 from the sulfide. The formula of the compound is Fe2S3. I hope you found this exercise useful. In the next video clip, we're going to look at slightly more tricky examples involving molecular ions. If you need help with your chemistry studies, this is where you can find me. Thanks for watching. Goodbye.